today we are going to continue discussing the limit laws or theorems, and we are now in the part 2 of our discussion. Last meeting we discussed about the limit of the sum and difference of two functions, and this time we will start with the fifth limit theorem. So this is our fifth limit theorem. This is the limit of the n power of a function. So it states that if limit of f of x as x approaches a is equal to L, and n is any positive integer, then if we are asked to find the limit of the n power of the function as x approaches a, then all we have to do is to get the limit of this, which is L, then we raise it by the exponent n. Okay? So to give you an example, we have this one. Example. Suppose we are given a function f of x is equal to x squared. Okay. Now find the limit of f of x as x approaches to 4. Okay. So how can we solve it? We can solve this one by applying this theorem. So let f of x be equal to x squared. Then limit of f of x as x approaches to 4 is simply equal to what? What is our f of x? It's x squared. So limit of x squared as x approaches to 4. Okay? Next is, take note that we only have discussed about the limit of the identity function, right? And since we have the exponent 2, so this can be written as, it's simply that we have a function which is an identity function. So we have to get the limit of this identity function first. So it's like limit of x as x approaches to 4, then you square it. Okay? So find the limit of x as x approaches to 4. So this is equal to what? It's equal to 4. Simply substitute 4 to the variable x. Since this is an identity function and this is a linear function, you square it because of the exponent 2. So you have 4 squared, which is equal to 16. In other words, the limit of the function x squared as x approaches to 4 is equal to 16. Okay? Okay. For the next example, or for the next theorem, we have the limit of the sum and difference of n functions. Now, in the part 2 of our discussion, we talked about the limit of the sum and difference of two functions. But this time, we will still be using the concept of limits of the sum and difference, but not for two functions only. It will be two or more, but the concept is still the same. Okay? So we read the theorem. If limit of f sub 1 of x as x approaches a is equal to L sub 1, limit of f sub 2 of x as x approaches a is equal to L sub 2, and so on up to limit of f sub n of x as x approaches a is equal to L sub n, then the limit of the sum and difference of each function is this one. The limit of f sub 1 of x plus or minus f sub 2 of x plus or minus and so on up to f sub n of x as x approaches a is equal to L sub 1 plus L sub 2 plus or minus L sub 2 plus or minus L up to L sub n. Okay? Now, how did we get this? So take note that the limit of f sub 1 of x plus or minus f sub 2 of x plus or minus up to f sub n of x, okay, as x approaches a, can be written as what? We can distribute the limit of each like having the distributive property. Limit of f sub 2 of x as x approaches a, plus or minus up to, okay. By the way, it's the limit. Let's erase this one. Okay, so let's continue, plus or minus the limit of f sub n of x as x approaches a. Okay, now by the assumption, we have limit of f sub 1, this one. The limit of f sub 1 of x as x approaches a is what? It's L sub 1. So this is L sub 1. Now about this, the limit of f sub 2 of x as x approaches a, it is L sub 2. So we have to plus or minus L sub 2 and so on up to the limit of f sub n as x approaches a is L sub n. So this is L sub n. Okay, so this is how we get this formula. How we come up with this L sub 1 plus or minus L sub 2 up to L sub n. Okay, so as an application, we have here an example. Okay, as our example, okay, so example number 1, suppose we only have 3 functions. Let's say f sub 1 of x is equal to 3x plus 4. Then f sub 2 of x is equal to x minus 1. And f sub 3 is equal to x squared plus 2x minus 1. And actually, we can have n functions, so more than 3 functions. But in this example, we only have 3 functions. So find the limit of f sub 1 of x plus or minus f sub 2 of x plus or minus f sub 3 of x as x approaches to 3. So how can we solve it? So first, solution. Limit. So limit of f sub 1 of x. So we have to write it in step by step. F sub 2 of x plus or minus f sub 3 of x as x approaches to 3. By applying the previous formula, the sum and difference of n functions, we can have the limit of f sub 1 of x as x approaches to 3 plus or minus the limit of f sub 2 of x as x approaches to 3 plus or minus the limit of f sub 3 of x as x approaches 3, right? So since what is f sub 1, we just simply substitute. So we write the solution in step by step siya. So all we have to do is just to follow the formula. So what is limit of f sub 1 of x as x approaches to 3? We don't know yet, right? So all we have to do is to get the limit of f sub 1 of x first as x approaches to 3. So we just simply substitute the function f sub 1. So limit, what is f sub 1? 3x plus 4 as x approaches to 3. Plus or minus, what is f sub 2? X minus 1, right? So limit of x minus 1 as x approaches to 3 plus or minus, what is f sub 3? This is equal to the limit of x squared plus 2x minus 1, okay, as x approaches to 3. Okay, so we have linear functions, these two functions, and we also have the quadratic function. But in this quadratic function, we can use the and power. Okay, so we can have, we can simply substitute this one because this is a linear function. So 3 times 3, what is 9, right? Plus or minus. So simply substitute 3 to this variable. 3 minus 1 is 2. Okay, plus or minus 3. 3 squared, this is 9. So 3, this is 3 squared. Okay, plus 2 times 3 minus 1. So this is 9. So 9 plus 6 minus 1, right? So we have 13 plus or minus 2 plus or minus 9 plus 6 is 15 minus 1 is 14. So for the addition, we have 13 plus 2 is 15 plus 14 is 29. Okay, that's for the addition. How about for the subtraction? 13 minus 2 is 11. Minus 14, the answer is negative 3. Okay? Do you have any comment? Okay, if you have comment, you can post it in the comment section or you can email that to me. Again, 13 plus 2 is 15, plus 14 is 29. For the difference, 13 minus 2 is 11. 11 minus 14 is what? Negative 3. So negative 3. Okay? So that is how we use the limit of the sum and difference of n functions. And in this case, we have 3 functions. Okay? Okay, for the seventh theorem, limit of the product of two functions. Now it states that if limit of f of x as x approaches a is equal to L, and limit of g of x as x approaches a is equal to m, then we just simply get the limit of the product. So limit of the product f of x and g of x as x approaches a is equal to L times m. Okay, how did we get this? Take note by the assumption that limit of f of x times g of x as x approaches a, we just simply distribute the limit. Limit of f of x as x approaches a times the limit of g of x as x approaches a. So take note of this, the limit of the product is equal to the product of the limit. Okay? So by the assumption, we have what? The limit of f of x, which is equal to what? L, right? So this is L times the limit of g of x as x approaches a is equal to m. That's why we have this formula. The limit of the product of f of x and g of x is equal to L times m. Okay? So for the example, if f of x is equal to 3x minus 1, g of x is equal to 4x plus 2. Find the limit of what? The product of f of x times g of x as x approaches to 2. So, ang solution natin dito, we just simply equate this one to the limit of f of x as x approaches to 2 times the limit of g of x, okay, as x approaches to 2. And what is our f of x? The limit of 3x minus 1 as x approaches to 2 times the limit of what? Of 4x plus 2. This is 4x plus 2 as x approaches to 2. Take note that we just simply substitute this one. So 3 times 2 is 6, minus 1 is 5. So 5 How about this? 4 times 2, 8 plus 2 is 10. So times 10, therefore the limit is 50. In this case, it is 50. Okay? So again, the limit of the product is equal to the product of the limit. Okay, for the A theorem, the limit of the product of n functions. Now, in the previous theorem, the product of two functions only. Okay? So just like finding the limit of the product of two functions, finding the limit of the product of n functions is like that. Okay? We just simply multiply the limit of each function. Okay? So if we know the limit of the first function, which is equal to L1, and the limit of the second function is L2 up to the n function, and the limit is L sub n, so we just simply multiply the limit. The limit of the product of f sub 1, this is f sub 2, up to f sub n of x is equal to L1 times L2 times another function up to L sub n, another limit of the function. Okay? So for example, suppose we only choose the simple or simplest example, f of x or f sub 1 of x is equal to x squared plus 1. F sub 2. F sub 2 of x is equal to 3x minus 4. What we after here is the process. So f sub 3 of x is equal to, what else? 2x plus 5. So find the limit of f sub 1 of x times f sub 2 of x times f sub 3 of x as x approaches to 1. Okay? How can we do this? We just simply follow the formula. Okay? What's the formula? Now, for the shortcut, since we know already the process, we can have the limit of this, right? What's the limit of this? What's the limit? Because L1, what's the limit of the first function? So you just simply substitute 1. So 1 squared 1 plus 1 is 2. 2 times, or we use this parenthesis. So what's the limit of this as x approaches 1? 3 times 1 is equal to 3 minus 4 is negative 1. And times the limit of this as x approaches 1. So 2 times 1 is equal to 2 plus 5 is equal to 7. Then simplify. This is equal to what? This is equal to negative 14. So the limit of the product of the three functions is equal to negative 14. Okay? Okay, for the next theorem, the limit of the quotient of two functions. Now, this states that if limit of f of x is equal to L as x approaches A, and limit of g of x is equal to m as x approaches A, then this one holds. Okay? This is what we call the limit of the quotient of two functions because we have quotient of two functions, like irrational functions. We have the numerator and the denominator. So all we have to do is to divide the limit of each function. So in other words, this limit of f of x over g of x as x approaches a can be written as like this. The limit of f of x as x approaches a over the limit of g of x as x approaches a. Okay? Now, by the assumption, the limit of this, limit of f of x as x approaches a is L, right? So this is L. Over the limit of g of x as x approaches a is m. So that's why we have a formula. The limit of the quotient of two functions is L over m, provided that m must not be equal to 0. Why? If m will be 0, then the whole function will be undefined. Okay? So for our example, okay. Now, another important thing in finding the limit of two functions, quotient of two functions, we have to determine first if the given function is in the simplest form. Okay? Meaning the expressions in the numerator cannot be factored anymore, so that if we can find a common factor to its denominator, this will be cancelled out. Okay? And simplified expression is left. Now, if if it's factorable pa, all we have to do is to simplify and factor it out. Okay? We have to factor it out if the given function is factorable pa. So after factoring it out, for example, we are given a function which is factorable. Then we were able to factor it out. Then after that, we can now proceed. We can now proceed using this theorem. Okay, using this theorem. So, for example, what's our example? Okay, we have this first example. First example, the simple or simplified function f of x is equal to x minus 1 over x plus 3. Okay? So the first thing that we are going to consider, we have to determine this first if factorable or not. Now take note, the numerator is x minus 1 and it's not factorable anymore, and also the denominator. Okay, so we can now directly proceed to the theorem that we have, finding the quotient of two functions. So solution, find the limit of f of x as x approaches to, let's say, 2. Okay, so for the solution, limit of f of x as x approaches to 2 is simply equal to the limit of what? What is our f of x? Is x minus 1 over x plus 3 as x approaches to 2. Okay? Applying the ninth theorem, limit, you have to get the limit of the numerator, x minus 1, as x approaches to 2 over the limit of x plus 3, okay, as x approaches to 2. Okay? Now, what is the limit of the numerator? This is linear again, so we can simply substitute 2 to the variable. So we have 2 minus 1 over 2 plus 3. So 2 plus 3, then the answer is what? 2 minus 1 is 1, 2 plus 3 is 5. Therefore, the limit of this function as x approaches to 2 is equal to 1/5. Okay, so this is the limit. Now, another example for the limit of the quotient function, quotient of two functions. Let's have another example. Example number 2. For example, our function is x squared plus 2x minus 3. Okay? Over x minus 1. Find the limit of f of x as x approaches to what? As x approaches to, let's say, what else? As x approaches to 1. Okay. Then earlier I told you that we have to determine first if the given function is factorable or not. Now in the numerator, for us to use immediately the theorem, we have to determine if this is factorable or not factorable in order to have a simplified expression. So let's have a solution. Okay, so we have limit of f of x as x approaches to 1. Okay. And this is equal to the limit of, now is this factorable? What are the factors of this? This is equal to, let's try, x plus, what else? X plus 3. Is this x plus 3? X plus 3, x minus 1, right? This over x minus 1 as x approaches to 1. Okay, let us check. This is x squared. X squared, okay. Then this is minus x. This is 3x minus 3. Okay, so we have x squared plus 2x minus 3. In other words, our factors x plus 3 and x minus 1, correct. Okay, they are correct. Okay, so let's erase this one first. This one. As erase to make this clear. So this is equal to limit of f of x is equal to what? X plus 3, x minus 1, right? Now, take note that we have common factor in the numerator and denominator. So this will be canceled out. Because if we directly use the theorem, that is finding the limit in the numerator and denominator, if we do that, we can have, in the denominator, we can have a value of 0, right? So it cannot be. That's why factoring this out first is very, very important. So we have to simplify this one. So this can be canceled. So we have the limit. By the way, we have to put limit here. So limit of this. So this becomes the limit of x plus 3 over, no, there's no over because, so this is only equal to x plus 3 as x approaches to 1, right? So it's easier now to find the limit of x plus 3 since this is linear. So we just simply substitute this one. So 1 plus 3 is equal to 4. Okay, so therefore the limit of f of x, this is our f of x as x approaches to 1, is equal to 4. And again, using the numerical investigation, you can also check if our answer is correct. Okay? Okay, so for the last, in part 2, for the last theorem in our part 2 discussion, we have this last one, the limit of the nth root of a function. So if n is a positive integer and limit of f of x is equal to L, then the limit, as x approaches to a, by the way, then the limit of the nth root of f of x as x approaches to a is equal to the nth root of L. So in other words, suppose we have a given function, okay, and we know the limit is L, and we want to find the limit of the nth root of that function, then all we have to do is just to get the nth root of the limit. Okay, so for example, suppose our function is square root of x. Okay, now find the limit of f of x as x approaches to 5. So this one, we can have what? How can we solve this? By the way, class, let's go back here first. This is nth root of L because limit of nth root of f of x as x approaches a is simply equal to the nth root of the limit of f of x as x approaches to a. And since the limit of f of x as x approaches to a is L, right? By the assumption, so we have the nth root of L. That's why the formula is this one. The limit of the nth root of f of x as x approaches a is equal to the nth root of L. Okay? So we have to erase this one first. Let's erase. Okay. So let's go back here. Let's go back to our example. So find the limit of f of x as x approaches to 5. So solution, find the limit of f of x as x approaches to 5 is simply equal to the limit of the square root of x as x approaches to 5. Okay, then using this, applying the 10th theorem, this can be written as the square root of the limit of x as x approaches to 5. Okay, then this is an identity function, so we can simply substitute 5 to the variable. So we have the square root of 5, which is our answer. Okay, so another example. It's an example that is a combination of rational function as well as the nth root of this. So another example. So find the limit of the cube root of x plus 3 over x minus 5 as x approaches to what? As x approaches to 6. Okay, how can we solve this one? So this is simply equal to what? Solution. This is simply equal to the limit of the cube root of x plus 3 over x minus 5 as x approaches to 6 is equal to what? The cube root of the limit of x plus 3 over x minus 5 as x approaches to 6. Then applying the limit of the quotient of two functions. So this is cube root of the limit of the numerator as x approaches to 6 over the limit of the denominator x minus 5 as x approaches to 6. So this is simply equal to what? The cube root of 6 plus 3 is 9 over 6 minus 1 is what? 6 minus 1 is 1. So we just simply substitute. We can have the cube root of what? Applying the property of nth root, we have cube root of 9 over cube root of 1. Now, cube root of 1 is 1, so we have cube root of 9. What's the cube root of 9? Okay, what's the cube root of 9? So since we do not have, we don't want to convert this one in decimal form, so we can have as the cube root of 9. Okay, so that's it. That's how we find the limit of the nth root of a function. So those are our next 5 theorems of limits or laws. Okay, so that's it. Hope you like this video and hope you learned something from this video. Don't forget to share the learning that you've got from this video. Okay, once again, thank you very much and God bless.